Hello, welcome to the 8th grade math standards practice. In this lesson, we'll be focusing on reviewing ordering decimals, fractions, percents, and numbers written in scientific notation. So let's go ahead and begin. So number 1 says, identify each number between 3.7 and 395%. Okay, so what you have to realize is that we need to convert these numbers into one format in order to compare. Okay, so I'm taking a look at 3.7 and 395%. So it only makes sense to convert 395% into a decimal number. So let's go ahead and do that. So remember, there is an unwritten decimal point behind the 5. So you're going to take that and move it 2 places over to the left. So that gives you 3.95. So what we're doing is looking for numbers between 3.7 and 3.95, okay? So notice the list of numbers here. So we have different formats. We have scientific notation as well as mixed numbers. So let's convert these into decimal format. So we have 3.6 times 10 squared. So taking a look at the exponent of 2, this is telling us to move the decimal point over 2 places over to the right. So let's go ahead and do that. And when you do that, you get 1, 2, which is 360. Now ask yourself, is 360 between 3.7 and 3.95? It is not, so we can cross this out. What about 3 and 8/9? So let's go ahead and convert this into decimal format. So first things first, since this is a mixed number, let's convert it into an improper fraction, and from there we'll go ahead and divide, okay? So we have 9 times 3, which is 27, plus an additional 8 is 35. So this is 35 over 9. All right, and so let's go ahead and divide. So we have 35 divided by 9. We'll place decimal zeros here to help us out. Bring up the decimal point. Now you need to ask yourself, how many times does 9 go into 35 without going over? And that is 3 times. 3 times 9 is 27. Take 27 from 35. That leaves you with 8. 9 goes into 8. It doesn't go in, so we have to bring down the 0. However, 9 does go into 80, and it goes into 80 how many times without going over? And that is 8 times. 8 times 9 is 72. Okay, and this is 8. Bring down your 0. And as you can see, this is a repeating decimal, okay? So we can leave it at 3.88, all right? And if you take a look, 3.7 and 3.95. All right, well, 3.88 is between 3.7 and 3.95. Okay, so that is a choice here. So we'll go ahead and circle that. What about 3 and 1/6? All right, again, we can turn this mixed number into an improper fraction, and then we can go ahead and divide. So that's 19 over 6, right? So that's 19 over 6. And we'll go ahead and divide that. So 19 divided by 6. We'll place decimal zeros here. Bring up the decimal point. 6 goes into 19 3 times without going over. This becomes 1. 6 doesn't go into 1, but 6 does go into 10. How many times without going over? And that is once. Okay, this is 4. Bring down the 0. 6 goes into 40 without going over 6 times. And so we'll leave this as 3.16. Now, we could have just stopped here at 3.1 because we know that 3.1 is not in between 3.7 and 3.95, right? So we can go ahead and cross this out. And last but not least, let's take a look at 3.71 times 10 raised to the 0 power. And what I want you to realize is this. We usually take a look at the exponent to see how many times we have to move the decimal point over, whether it's to the left or to the right a certain amount of times. However, any number raised to the 0 power is always equal to 1. So essentially what you're doing is you're multiplying 3.71 by 1. So remember, any number multiplied by 1 is that number. Therefore, 3.71 times 1 is 3.71. Now, is 3.71 between 3.7 and 3.95? It is. So this is definitely a choice here. Okay, so let's move on to question number 2. So for number 2 is asking, what is 304 million expressed in scientific notation? So here we have our answer choices. So we see that they're all written in scientific notation. So look at the first part, is 3.04. So this is telling us that the number has to be written between 1 and a number that's greater than or equal to 9 but less than 10. Okay, the second part is always 10 raised to some power. All right, so now how do we express this in scientific notation? Which one is the correct choice here? So let's rewrite 304 million right here. Okay, and what I want you to see is that there is an unwritten decimal here. Okay, so you have to write this, this number has to be between 1 and some number greater than or equal to 9 but less than 10. All right, so when we do that, we're going to move the decimal point 1, 2, 3, 4, 5, 6, 7, 8, right? So if you notice, it's between this 3 and the 0, 4. Okay, so that's this first part of the number. So how many times did we have to move this decimal point? Again, we moved it 8 times. So that means that the second number, 10 raised to some power, is going to be that power of 8. So the correct answer is answer choice B. Now, another way you can look at this is to say, well, how many numbers are between the two decimal points? So we have one here and one here. And you know that the decimal point is going to be here because remember, it has to be between the numbers of 1 and greater than or equal to 9. So how many digits are in between these two decimals? So you can count them up. There's 3, 6, 7, 8. Okay, so that's another way to look at that. All right, so now let's go ahead and go on to question number 3. So for question number 3 is asking us which statement is true. Okay, so we have, for letter A, we have 0.07 is greater than 7/9. Well, can we tell which one is greater than or less than? Well, we can't really, so let's go ahead and divide 7/9. Okay, so let me change the color here. Okay, so we have 7 divided by 9. And I'm going to place decimal zeros right here to help us out. Bring up the decimal point. 9 goes into 7 0 times. However, 9 does go into 70. How many times without going over? So that is 7 times. And that 9 times 7 is 63. This is 7. Bring down your 0. 9 goes into 70. How many times without going over? And we can say that is 7 times. All right, and we'll stop it right there. So this is 0.77, right? So 0.07, is that greater than 0.77? It is not. So answer choice A is not correct. That's not true. So now we have 4% is less than 0.07. Now, if you can recognize that you can convert this decimal number into a percent, then you're fine, because all you're doing is taking this decimal point and you're moving it 2 places over to the right, right? So remember that there's an unwritten 0 right here. So essentially it's the same value as 7. 7.0 is the same value as 7. So 4% is definitely less than 7%. So this is the correct answer here. But for peace of mind, Let's go over the other answer choices. So we have 7/9, which we said was already 0.77. So is 7/9 less than 6.0 times 10 raised to the negative third power? Well, this -3 is telling us to move the decimal point over 3 places to the left. Okay, so let's go ahead and do that. Let me write it right here. And we'll move that 3 places over to the left. 1, 2, 3. So fill in with zeros here. And we have 0.0060. So there's no way in the world that this is a true statement, right? Because 0.77 or 7/9 is larger than 0.0060. Okay? So this is out of the question. And last but not least, what about D? So we have 6.0 times 10 raised to the negative third power. So we already said that that's equal to 0.006, right? And then we have 4%. 4%, when you move that over or change this into a decimal, you're just moving the decimal point over 2 places to the left. So let's go ahead and write that here so you can see. And there's an unwritten decimal point right here. So move it over 2 places to the left. 1, 2, 0.04. So there's no way in the world that this number is greater than this number, right? So this is out of the question as well. All right. So let's go on to question number 4. So question number 4 asks, which list is ordered from least to greatest? So I'm looking at the answer choices and I see that I have a different variety of numbers. So I have percents, I have fractions, I have decimals. So what I'm going to do is select one of these lists and I'm going to convert these numbers into just one format. To make it easier, I'm going to convert them all to decimal format. So I'm just going to use list A, okay? So we'll take 7.2% and we'll turn that into a decimal, same with 5/7 and 8/11, okay? So 7.2%. So if you take a look here, we see that the decimal point is here. So this is telling us, or this percent actually tells us, in order to turn it into a decimal, you move the decimal point 2 places over to the left. Okay, so 7.2% is equal to, and let me just rewrite this in a different color. So we have 7.2, moving the decimal point 2 places over, that's 1, 2. So that is equal to 0.072 or 0.072. Okay. What about 5/7? So this is a fraction, so we can go ahead and divide. So we have 5/7. Let me just rewrite that like this. And we have 5 divided by 7. We'll place decimal zeros here. 7 goes into 5 0 times. 7 goes into 50 7 times. 7 times 7 is 49. Okay, this is 1. Bring down the 0. 7 goes into 10 without going over, and that's once. So we'll leave this as it is, so 0.71. So this is equal to 0.71. And I'll place a 0 at the end here. All right, and next we have 0.72. So we can leave that as it is. So we have 0.72. But to help us out, we'll place a 0 here. It's easier to compare when the decimals are lined up. And then we have 8/11. Okay, so this is 8/11. Let's divide. So 8 divided by 11. So we'll place decimal zeros here. This is 0. 11 goes into 80. How many times without going over? That's 7 times. So this is 77. Okay, 3. Bring down your 0. 11 goes into 30 without going over twice. So that's 22. So we have 0.72 here. However, it's not the same value as this, so we have to extend this out a little bit more. So place 0 here. 10 minus 2 is 8. Bring down this 0. 11 goes into 80 without going over 7 times. So this is actually 0.727. We can stop it right there. Okay. So 8/11ths equivalency is 0.727. Okay. So now let's take a look at what we have here. So we have, let's place these in order from least to greatest, okay? So we have the whole numbers position all contain zeros. Let's look in the tenths place. So we have, this is the only number that contains a 0 in the tenths place. So this means this is the smaller value. So we can actually go ahead and eliminate answer choices from here. Okay, so we know that 0.072, which is the same as 7.2%, will be first. Okay, so that means we can eliminate choices B and we can eliminate choice D. Okay, so we're left with A and C. So now let's continue further. So both A and C has 7.2% as the first, 5/7 as the second. All right, let's move on to the third, 0.72 and 8/11ths. All right, so we have this as the smaller value, 7.2%. The next smallest value is 0.710 because 710 is smaller than 720 and 727. So that means 5/7 is next. Okay, both, like we said, contain 5/7. What about 0.72 and 8/11ths? All right, so next in line is 0.72, which is just that. I just tagged on the zeros to help us out as far as determining which is smaller and larger. And then we have 8/11ths here. So that means the correct answer choice is answer choice A, because 8/11ths is equal to 0.727, right? And there's no way that 0.727 is less than 0.72, okay? So that means, I meant to say that 0.72 is less than 8/11ths, right? So, because this is 0.720 and this is 0.727. So this can get a little bit tricky, so that's why it's always good to double check. All right, but the correct answer is answer choice A. Okay, and as you can see, just to reiterate, let's look at it again. We have 0 here, the rest are 7s. Okay, so we know this is the smaller one. And then we have 7. Then we're comparing 710, 720, 727. All right, and so this is the correct answer. All right, so let's move on to the next problem. Okay, so here we are told to rank the following values in ascending order. All right, so first of all, what does this word ascending mean? So it simply means from least to greatest, okay? So remember, ascending begins with the letter A, so I like to think of this like the ABC, so A to Z, so from least to greatest, okay? So what we're going to do here is, since we have fractions and percents, we have decimals, we're going to convert these all into decimal format to help us compare, okay? So let's start with 1/8. So 1/8 we can simply divide. So 1 divided by 8, if you don't already know what that is as a decimal. But 8 goes into 1 0 times. 8 goes into 10 without going over once. Subtract 8 from 10. Bring down your 0. Oops. And then 8 goes into 20. How many times without going over? That's twice. So that's 16. I meant to place an additional 0 there, but 10 minus 6 is 4. Bring down the 0. 8 goes into 45 times. So this is 0.125 as a decimal. And then we have 12%. So remember, to turn a percent into a decimal, you have to move the decimal point 2 places over to the left. So there is an unwritten decimal point here. You're just moving it over twice, 1, 2. And so that's 0.12. Okay, and we can leave this as it is, 0.127. And then we have 2/15, so we can convert this into a decimal by dividing. So 2 divided by 15. Place decimal zeros here. Okay, 15 goes into 2 0 times. 15 goes into 20 once. That's 15. All right, and this is 5. Bring down the 0. And then this is 3 times. So that's 15 times 3 is 45. And then 10 minus 5 is 5. Bring this down one more time. And that is 15 goes into 50 3 times. So this is 0.133 repeating. All right, so now since we have these values, we can place them in order from, and like I said, ascending simply means from least to greatest, okay? So we have 0.125 and then 0.120. So let's actually line these up vertically to help us see what we're looking at. So this is 0.125, and then we have 0.120, 0.127, 0.133. Okay, and so we don't get confused. This is equivalent to 1/8. This is 12%. Of course, 0.127. And this is 2/15. All right, so let's rank these. So we have zeros. These are all in the whole numbers position. So the same thing there. Tenths place are the same, and then we have 2, 2, 2, and then 3. So we know already that this is the larger value, right? So we'll place 4. So we'll just rank them using the numbers 1 through 4. Okay, and then let's see. Let's go ahead and cross this out. All right, and so now we have, let's look at the 5, 0, 7. All right, so from least, so which one is least? So we have 125, 120, 127. So this is 12% is the least, so that's 1. All right. Next. 125, 127. So which one is next? The next least is 1/8. So that's number 2. And then we have number 3. Okay. So that means that 12% is the smaller value, followed by 1/8, then 0.127, then 2/15. Okay. So that's how you rank these values in ascending order. All right, so let's move on to the last question, number 6. Okay, so for this last problem here, we need to rewrite 1.2926 times 10 raised to the 0 power in standard numeric form. Okay, so as you can see, this is written in scientific notation. So we have to write it in standard form as it's telling us to do so. So remember, when we take a look at the exponent tells us to either move the decimal point to the left or to the right, depending on whether it's negative or positive. Well, in this case, the exponent is 0. So this 10 is being raised to the 0 power. So what does this mean? Well, it simply means that 10 raised to the 0 power is 1. So all you're doing is multiplying 1.2926 by 1. And that leaves you with 1.2926. Because remember, anytime you multiply a number times 1, it equals that number. Okay? So that's all we have for this lesson. Hopefully it was helpful to you. And I look forward to working with you in an upcoming lesson. Take care.